So in this video, it is a simple introduction about the meaning of an infinite series, and is essentially an infinite sum of many numbers. And let's look at the current problem. So I would like to ask you whether you can predict what's happening to an infinite sum of numbers. Let's assume that you actually know all the numbers. So you can imagine the process that you are doing by calculator. I give you all the numbers. You just keep adding them. And in this case, we need to classify two categories of problems. If the sum is actually approaching a fixed number, then we can call such a series convergent series. Otherwise, we call it not convergent. And obviously, the answer to this problem depends on the numbers a1, a2, a3, which are given to you. And as a simple example, let's look at the current case. Please look at the current problem where you're given numbers like 1 minus 1 plus 1 minus 1 and forever. And if you keep doing it forever, please imagine what you are getting. Of course, the first number is 1. The second number, which is the sum of the first two numbers, is actually 0, right? And if you look at the sum of the first three numbers, you're actually doing 1 minus 1 plus 1, which is actually 1. So you can see what's happening for the sum of the first four numbers. The answer is actually 0 again. And if you keep doing it, you can take a look at the sequence of the numbers here in this column. We expect that it keeps alternating between 1 and 0. And in this case, we cannot call it a convergent sequence because the actual infinite sum is not converging to a fixed number, right? Let me write down the answer here. And you see, we can say the series is not convergent in this case. And let's look at more examples now. So how about this case? I'm giving you some numbers to add, and all of these are positive now. You see, obviously, we expect the sum to get increasing forever when we keep adding the numbers like this. And there's a chance it is actually approaching a fixed number, or it may not be approaching any number. We have to check it more carefully. You see, now the key point is that each time when you go to the next number, you're actually multiplying by half to get to the next number. And I'm asking you to add a sequence of numbers like this. And for those of you who have learned something about the geometric series, you would automatically see what I'm doing here. But let's say that you haven't seen anything about the properties of such series. And what you are doing is you have to check the sum of each term one by one. For example, the first number is 1, right? And the second one is the sum of the first two numbers. In that case, you're getting 1.5. And the next one, you're adding up three numbers like this, you're actually getting 1.75. And the next one is the sum of the first four numbers, you're actually getting 1.875. And you can actually keep going for this process. And the fact is that if you purely check it by calculator, maybe after 100 numbers are added up together, you notice that it actually approach when you keep doing this process for many times. Of course, if you are just having the five numbers like what I'm doing here, it is not enough to convince you what's happening afterwards, right? But you have to do it for quite many times, maybe at least 100 times. You can notice that it actually approaches the number 2, which means that the sum at the end, you won't see the number getting above 2. It just keep approaching 2 at the end. And it looks like the answer is convergent to 2. Let me write down the answer here. So you can look at the answer I wrote down in the purple box. It looks like that by the use of calculator as a numerical check. And in that case, if it is true, of course, we can call it convergent. And we'll look at it in a more mathematical way in the videos in the future. And let's look at one more question here. So please look at the current problem. It looks slightly similar to the last one, but actually the terms are not the same. Every time now you're adding the next term is like 1 over 2, 1 over 3, 1 over 4, and etc. And this infinite sum, we call it the harmonic series because it is a famous series in the mathematical topics here. And you can try to predict what's happening here when you keep adding the terms. You see, if you look at it intuitively speaking, the terms every time when you get going, like you look at the future terms, the next term obviously is smaller than the previous term, right? And the term itself is actually getting smaller and smaller, kind of like it's approaching 0 for the term itself. So it seems that It can be a convergent series like the last one, right? But actually, it is not a correct prediction. If you try to do it by calculator one by one, the first number is just 1. The second number, if you add the first two, it is 1.5. For the next one, you're adding three numbers together. It's going to be 1.833 and so on. For the next one is the addition of four numbers. You get something like 2.0833 and so on. And for the next one, you're adding five numbers. You actually get 2.2833 and so on. You see, now the numbers are increasing. They are increasing in a different way if you compare it with the last problem. And the fact is that if you keep doing it for many times, it looks like it is not approaching a fixed number like the last problem. So please look at my writings here. It doesn't approach a fixed number, and it actually looks like it is not convergent when the sum keeps increasing like this without any limit. And this answer is actually true. When I ask you whether it is convergent or not, of course, it is not a reasonable way to ask you to do it by calculator every time, right? And it's a much more mature way to actually answer it in terms of doing the mathematics and understanding the mathematical reasoning behind the problems. And that's the key goal of this topic of asking you whether certain infinite series is convergent. And there are so many methods to learn to check whether something is convergent or not. It will come up in the next couple of videos.